So today's topic is electrolysis, and before the end of this lesson, I need you to understand the following objectives. I want you to understand what electrolysis means, what an electrolyte is, the different electrodes that are used in electrolysis, and how electrolysis actually occurs, the reactivity series, and the first two rules of electrolysis. Okay, so we're just going to start by defining electrolysis. So basically, simply, electrolysis means you're breaking down a compound into its simpler elements. Udirisa electricity. You're using electrical current. You are passing down an electrical current to break down a certain compound. So this is a process that wouldn't happen otherwise. Hence, we use a method called electrolysis. So let's say, for example, we have sodium chloride solution. So to break down that sodium chloride solution, we will then pass over the electrical current to break it down into sodium, then chlorine, then hydroxide ions, then hydrogen ions. So those are all the ions. You're breaking down that compound into simpler elements. That's basically electrolysis. Okay. Then you have something called an electrolyte. So an electrolyte, this is an ionic compound in the molten or aqueous state. When you say something is in a molten state, it means that it has been melted. And then when you say something is in aqueous state, it means that it has been dissolved in water. Okay? So in that electrolyte, we have ions. And these ions, they move freely and they are attracted to electrodes. Okay? So we have the two electrodes. Our two electrode, we have an electrode called the cathode and another one is called the anode. So the cathode is a negatively charged electrode. Again. And then the anode is positively charged. And because the cathode is negatively charged, what is going to attract because it's negatively charged, it's going to attract positive ions. And the positive ions, more chemistry, the cat ions. So cathode, which starts with C, attract cat ions, which starts with C. Cathode, cat ions. Okay? And then anode, which is positive, attract the anions. So it's AA. And the anions, those are what? Are negatively charged ions. Okay? Or you can basically say cathode, attract the metals. Remember that metals lose electrons to become positively charged. And then the anode, attracted the non-metals. Remember that non-metals gain electrons to become negatively charged. So that's basically it. Other electrodes that we have, those are called the inert electrodes. So inert electrodes, they do not react. Okay. So you want to use those inert when you don't want them to interfere with your electrolysis process. That's when we're saying the inert electrodes. So we have platinum, graphite, carbon, or known as carbon also, and gold. Moving on. Now, I'm going to explain to you how electrolysis actually occurs. Again, so if you take a look at this diagram, we have our power source, which is our battery. This power source, it will send the electrical current through the electrolyte via our electrodes, which is the cathode and the anode. Again, so in the electrolyte, the compound, it is made of ions. It will move either to the cathode or anode. What is moving to the cathode should be what? Should be positively charged, because the cathode is what? Is negatively charged. And what is moving to the anode should be negatively charged, because the anode is positively charged. Okay? Now, at the cathode, you need to also understand that reduction actually takes place. Reduction, remember what it means. Reduction is the gaining of electrons. And then at the anode, oxidation is taking place. And remember that oxidation is the laws of what? Of electrons. And then the end result of this entire process will be the separation of the original compound into simpler substances. Because at the end of the day, we're going to have our compound separated into simpler substances. If you're having sodium chloride, which was molten, you will now have sodium ilico separated and chloride ions dilico separated. Okay, so that's it. Now, we have rules in electrolysis. So the first rule highlights to master your reactivity series. That's the first rule that you need to know. You have to master your what? Your reactivity series. Okay, so I'm going to start with the most reactive to the least reactive. So the most reactive is potassium, and then the least reactive is gold. So there's a statement that I wrote there. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. Please stands for potassium, stop sodium, choline, calcium, Me, magnesium, Air, aluminium, Careless, carbon, Zebra, zinc, Helaya, loyal. So you're writing that statement so that you do not forget your reactivity series is young. So potassium is the most reactive, followed by sodium, calcium, magnesium, and then the least reactive, gold. So you need to know that reactivity series. Okay? Now, moving on, the other rule, Yari, I want you to focus on those circles that I've drawn there. So the rule number 2 says, at the cathode, the less reactive metal is the one that is produced. And then at the anode, oxygen gas is produced unless you have halide ions. Halide ions ke halogens. So if there is a halide ion, it means in this case, a halogen will be produced instead of oxygen gas. But if you have any other ion and it's not a halide ion, then oxygen gas is what is going to be produced. Okay? Now, that's the rule. So rule yar nayaring at the cathode, what is less reactive is going to be produced. Again. And this rule only applies when you are given an ionic solution. But first, what do we mean, harare ionic solution? What do we mean by that? Again, so when you're saying you're having an ionic solution, let's take, for example, sodium chloride solution. Sodium chloride solution basically means sodium chloride is dissolved in water. And because sodium chloride is dissolved in water, the ions that are present in this solution, ki sodium, ki chloride, and then because it's dissolved in water, we also have hydroxide ions, which is OH minus from the water. And then we have the H plus from the water. So we have sodium ions, chloride ions, OH minus, and then H plus. Those are the ions that are present. Okay? So we have the ions of those, the ions that are present are those of the ionic compound and those that are in the water. Okay? Now, the other thing that you need to know more electrolysis, what is produced at the cathode and what is produced at the anode. So remember, the cathode is what? Is negatively charged. So the ion steady anko cathoding will be the hydrogen ion and the sodium ion. So between hydrogen and sodium, what is less reactive is going to be produced. Again, so which means between sodium and hydrogen, what is produced? If you go back to your reactivity series, you realize that hydrogen is less reactive in the reactivity series. And because it's less reactive, it is the one that is going to be produced at the cathode. So at the cathode, hydrogen gas is what is produced. And then let's go to the anode now. At the anode, we get oxygen gas. Or if there is a halide ion, then that halide ion is the one that is what? That is being produced. So in this case, at the anode, what do we have? Renalo OH minus, which from it we can get an oxygen gas. Aberinali Cl minus. Cl minus is a halide ion. Because it's a halide ion, oxygen gas is not going to be produced. So what is going to be produced is going to be chlorine gas. So at the anode, chlorine gas is produced. So that's it for today's lesson.